For my project, I used CNNs to identify the street house numbers on real-life images. I used 4 different CNN approaches: VDG16 with pre-trained weights from ImageNet, then VDG16 with random weights, and then I built my own VDG16 custom architecture where I reduced the model to 13 layers with smaller inputs, 64 by 64. And finally, I built out a CNN based on Goodfellow's paper that had multiple output classes for each digit. Initial results are shown here below. We can see that the Goodfellow model does best along with the VGG pre-trained model. However, the Goodfellow model takes much less time to train because VGG requires 224 by 224 images, which take a lot longer to train and are also more memory expensive. The random and custom models did really poorly, so I discarded those going forward. Then I tried data pre-processing. So far the model was trained only on the training set with a few negatives added. Instead, what I did was I went and added 200K more training examples using the extras data set. I randomly rotated images between 8 and 35 degrees. I randomly shifted images between 8 and 10 pixels, and then I added even more negative examples with no digits using the 200K extra data set. So after augmenting the training set with 500K more training instances, I then trained again, and I saw that my validation loss, here the orange line, for the Goodfellow CNN is a lot less than before. It's 0.5 versus 1.1, 1.2 before. Same with training loss. And then in terms of accuracy, the accuracy jumped from 89% to 91.5%, although compared to the state-of-the-art Goodfellow paper, it's still lower, which I'm guessing is due to better parameter tuning done by the Goodfellow team. For parameter tuning, so I used 1 times E4 as my learning rate because it had the lowest validation loss, and then a small batch size of 32 because it helped reduce overfitting the most. Finally, I would like to show some results after applying localization using a sliding window over different scales. So here you can see scale invariance where one image is zoomed and the other is not, and both are classified correctly. Rotational invariance, you have counter and clockwise rotations in both orientations, and you can see collect classification. Then you have location invariance. So here the field of view is to the left and it still classifies correctly. And then most interestingly, you can see the lighting change here. There's a big reflection and sunlight falling on the 64, which is making it blurry, but it's still classifying it correctly. There were some failures. Extreme rotations still were struggling for the model. And then blurry images with reflections and kind of like low light still had like some issues with classification. So given more time, there are a few things I would have done differently. First, I would have used a random image generator instead of creating a static augmented data set, as that would increase training time. I could have used faster RCNN and more cutting edge techniques for localization instead of sliding window, and also image filtering techniques like MSCR filtering.